Total cost of ownership estimator. Large language models are often evaluated purely on API pricing or benchmark performance, but the real cost of deploying an LLM application depends on much more: infrastructure, scaling, optimization techniques, and engineering effort. This tool introduces a total cost of ownership framework for comparing LLM deployment strategies over time. The framework models both setup costs and inference costs. It also accounts for human resource costs, since optimization techniques may reduce inference expenses but require additional engineering work to implement and maintain. On the left, you can adjust all input parameters. In the center, you can see the key cost metrics for each model: setup cost, inference cost per 10,000 requests, recurring operational costs, and total cost of ownership. On the right, two pie charts visualize cost breakdowns for both models. Under the pie charts, two charts visualize cumulative costs over time. The top shows total cost per model, and the bottom breaks down setup versus inference. Let's work through a scenario: a custom service chatbot handling 10,000 requests per day. For Model 1, we use a commercial API, in this case OpenAI's GPT-4o, with 800 input tokens and 300 output tokens per request. And 40 hours of setup engineering plus 10 monthly operational hours. The total cost of ownership over 1 year is approximately 55,000 euros. For Model 2, we deploy the same model on cloud-hosted infrastructure, AWS SageMaker. Token prices are now 0, but we pay for GPU usage at 0.76 euros per hour. Setup engineering increases to 100 hours with 20 monthly operational hours. The inference cost per request drops significantly, but higher setup and operational costs bring the annual TCO slightly above Model 1. Now let's increase the load to 20,000 requests per day for both models. The picture changes. Model 1 starts cheaper, but after approximately 3.5 months, the cloud-hosted model becomes more cost-effective. You can see this break-even point clearly in the top chart where the two lines cross. The bottom chart explains why. Even though Model 2 has a higher setup cost, its inference cost grows so much more slowly than it eventually wins. The key takeaway is that the same language model can be cost efficient or expensive depending on workload scale and deployment strategy. This framework helps estimate when inference costs begin to dominate and when optimization strategies become economically justified. Rather than evaluating models on token pricing alone, organizations should consider the full total cost of ownership. Some parameters, such as cache hit rates or routing efficiency, are difficult to estimate in advance. and may vary significantly between applications. The framework is therefore designed for comparative scenario analysis. The goal is not exact prediction, but improved visibility into how architectural and operational decisions affect long-term LLM costs. Thank you.